Honorable Chief Justice, honorable representatives of justice sector, and distinguished participants. Actually, this is something that I think is very, very relevant to speak about for IECMS. I remember on the first day, Your Excellency, you told that you heard how actually some countries move forward by using artificial intelligence or machine learning or other techniques to improve the work that is being done in judiciary. Yesterday, we made a small surprise with the GIS functionality. So this is another surprise as well, that currently, at this moment, there is already implemented functionality of artificial intelligence in IECMS. Let me tell one story and then we'll continue. It will not take too long. When I was first hired in an IT company, it was very difficult for me. Imagine me, I am a project manager and I have many tasks from my clients. I have a team about 20 people. Each of them is specialized in doing some kind of tasks. Compare it to a president who is new to the court. He doesn't know the specification of judges, actually who is doing what very well. Or a new police office head who has been brought from totally another province. He has a very good staff, but maybe one is good at one type of crimes, the other is good at the others. The same can be at prosecution. The very experienced people have very good intelligence. Nowadays, after so many years with my team, I know exactly very well who of my team can do which task very well. And when I have 10 tasks and I have only 2 people available, I can give 6 to the one, 4 to the other, and I can guarantee the perfect time my tasks are all completed. So, as I was very green and I always wanted some miracle to help me, we found a way. What is actually artificial intelligence? There are thousands of definitions. One of them was given by our colleague, Dr. Rwandan, but actually it's about imitating human intelligence to make things go well. It's about teaching the machines. Usage of artificial intelligence actually in justice sector can be really very thousands of ways. One thing we will talk about, the other one, decisions. Yes, decisions can be automated somehow at a level. But there are other things which can be more interesting. Imagine you have cameras in the city and they are capturing automatically people with guns or people who have suspicious behavior. This is artificial intelligence. This is the vision in artificial intelligence. Imagine someone is, like my mom, had the national language processing artificial intelligence. I'll explain why. I was coming home and she was asking me, were you at school today? I was saying, yes, I was. She, were you at school today? I was saying, actually not the very, very last lesson. She was noticing that I was lying. So, tone of voice, positive or negative, natural language processing. Imagine if someone is talking in the court and system can say, there is something wrong with his voice, intonation, or even reading the decision, post-analysis, it can say this was done with negative mood. That is about natural language processes. Robotics, I think people who were here, they know, like Sofia, she was here. Or automated vehicles. Imagine if not the drivers, but the robots are transforming inmates from one place to the other. So usages are many. But we will concentrate on one of them. These were the functionalities in IECMS. And we told that we have intelligent case allocation. What are the challenges that we usually face? This may be not only in courts, this may be in any institution. The time it takes. We are always trying to perform better. Not reducing the quality, but reducing the time that we need. the less our case takes, the better is our justice. So time is one of the most important criteria. The same for investigation. The same for, I think, prosecution, and but for the prisons, the time is fixed, so we will not go too deep into it. When the time, it takes too much, it's always hard to increase resources. The same is for our side. If it takes too much for judges, even the developers, sometimes if our tasks take too much, we have a lot of tasks, we have backlogs. The same happens in courts. The same can happen in police. If you don't have enough time, it takes too much to investigate each crime, so your backlogs will increase. This brings to lack of resources. In ideal world, it will be good to have enough resources, but they are always not enough. And sometimes this can be one of the reasons, the inefficient allocation of resources. Imagine me first time assigning tasks to totally wrong people who didn't know how to do it, and it was taking a week, and then someone coming and telling me, you know, there is better way. Just give this ones to this person, this ones to the other, him, don't give any task. It became efficient. How to replicate it? That was the question we were asking. How to replicate that knowledge that some people have, the others don't? How we can help a very green person who just came and he needs help? So, first thing, we need to understand specialization. Because like I can say, like this judge is very good, for example, for civil cases. This one is the perfect whenever there is any commercial issue in the case. For criminal, we have someone somewhere else. And we should use intelligence. We should try to create an algorithm which can take the intelligence that president have, the skilled president of the court has, or police officer, or the others, to predict duration. Because when we see that this person does for 2 days, this person does the same thing for like 6 days, so the one which can finish the work in 2 days, it's much easier. So, and I will tell how we actually created that algorithm. How we how we analyzed how the president understands and how the system finds the correlation. What is important in the case, what is not important to predict. And currently in IECMS, it gives the prediction. When you select a judge in the system, it shows when the case will be closed. When you change the judges, this duration changes. And how this so results are good. We will go again to the result, but it can improve the decision making. Because sometimes people, when they speak about artificial intelligence, they say that its system is replacing. No, artificial intelligence can help you to make decision. It can be your decision to give to person A or person B, but someone like the one who was helping me when I was new in the company can like give me some hints. This one will be better. And it can optimize time. If you finish everything in a week nor in a month, so you get optimized time, you can reduce your backlogs. What we did, there are many, gosh, I was making this presentation and I was always pronouncing this word wrong, and he's smiling because he knows that I will pronounce it wrong again. Variables? Absolutely. Correct. More than 90 variables that were used. For example, we took number of parties, because we thought, first thing, we have case A, we have case B. One case has 2 parties, the other has 100 parties. So, number of parties is a variable. So, we took number of documents in the case, the size of the documents, the content of the file. So, information from case, information from parties, representatives, the cases that the judge worked, and we created a huge database so that, and which was the basis. So imagine me, if we were doing it not with artificial intelligence, imagine someone passing through all and every case and trying to understand which one has some effect. Then we created the heat map. We took all this, like when the case is submitted, when it's registered, its priority, its hearing date, assigned registrar, case duration, and tried to see, is there any link or not? This is one of the texting that the machine does. It's not we who try to understand all this color. It's the machine who says, under all those different parameters, is there any correlation? Because the sooner is the hearing date, the sooner your case has a probability to be closed. it's a positive correlation. But there are aspects like if case has more parties or less priority, it will go slower. So it is again a correlation, but a negative one. So for all the different 19 parameter system, try to understand what are the difference, the positive and negative correlations. And then, using the gradient booster algorithms in machine learning, we try to classify parameters. Cesar, can you please zoom a bit, the first 4 ones? Try to, which system came out with these suggestions based on the actual things. He told that the minimum hearing date is the most important parameter in any court case, based on 100,000 cases. That is the first parameter which decides when the case will be closed, or which gives an overall understanding. The assigned judge is, according to the data, the assigned judge is less important than the hearing date, but it's the second most important parameter. Then, size of documents, no matter what documents, but the size of documents. And in the beginning, we were wrong. Case with 2 parties can go faster than the case with like 100 parties. Because the one with 2 parties can have hearing date sooner, another judge, and less documents. So it will take less. Then all these other parameters up to down, plus another 90, system started analyzing. And we created a model which was learning and testing itself, like a robot. And then we say, good, we achieved more than 70% correctness. For me, when I was looking on a case, I was like, in the beginning, we were just having fun, writing, okay, 5 days, and then we were asking, and in the real life, it was like 20 days. We are not this clever. Our machine was doing it perfectly compared to us, with above 70% correctness. And last year, we got approval to implement this machine in ICMS. And we started comparing what is the system predicting and what are the real durations. This graph shows the real durations in real cases here and the predicted durations. So on the live testing, it shows accuracy of 71%. Cesar, can you zoom a bit? So for some cases, it just a day or 2 difference. For the others, it's the same. For the others, there are gaps. The gaps can come because not all the data is in IECMS. I mean, if in IECMS we had the vacation of judges, that could enhance the prediction. Like machine could say, okay, these cases that I thought judge long because they are difficult. No, because judge was on vacation or he got sick, he was not present. And other parameters. More parameters you fit the system, the better your model can be. But this model can be used practically by presidents who wants to see how long it will take for this person. It suggests. It doesn't say you need to choose. But this is a practical example how the artificial intelligence can help judiciary to allocate judges or allocate resources. And practically, this is not going into the real data. Practically, when a judge reporter is selected in the system, prediction comes automatically. When you change the judge, it brings new one. For some judges, it doesn't give any prediction because machine needs some data to learn on. If you have a new judge, it will not react. But if you have a judge with a history of cases, it brings the result. And it's self-learning. Periodically, the algorithm takes cases inside because the algorithm is here. It's not somewhere else. It's here in the data center. It passes through cases and they say, okay, something has changed. Now I must predict in this way. And after prediction, he checks the reality and then changes. So it's self-learning. This is just one simple example how artificial intelligence is working in ICMS and it can develop. Potentially, if we go this way, so there are many machine learning tools that we can use to predict durations. It can be not only judgment duration, the same we can have for registrars. Imagine a case coming to the court. You can have 5 front desk registrars. Who is the best one to take? Maybe this registrar is very, very fast checking everything for civil cases. Maybe this one is very good when there are, I don't know, many, many people and many documents. This one is working well for criminal. So system can suggest again to which one to give, just to reduce time. Every second one, using these algorithms, in the long run, can help to reduce the overall case duration. By this, we have improved decision making and we reduce the backlog. But the final thing we want to achieve, and we are making research, is actually to come to predictive analysis. Imagine that the system we tried, we have some results, but we are yet developing, and as soon as we finish, we will be glad to share the results. Imagine that system takes at the moment all the cases and predicts their durations. And then, using the analytical tool I show in ICMS, we make a report and say, okay, when our cases will be closed or how much our backlog will change. This is the very important thing. It's hard for 100 or like 5,000 or 10,000 open cases to predict. But if you have a tool like this, it can predict for you how much your backlog will be tomorrow or like in a year if you don't change anything. You make specialization of judges, but that is more about monitoring and evaluation. But these tools can help to enhance monitoring evaluations with the prediction manner. So, thank you.